And exciting and fast in world chemistry. We're looking at colligative properties today. Colligative properties are defined as properties of solvent that are changed as a solvent becomes a solution. When we become a solution, some properties change. These properties are freezing point depression, boiling point elevation, vapor point, and osmotic pressure. Now, we didn't do as well as I'd like to because of last year, but the first two we did look at last year and beginning of this year. The equation there for freezing point depression is delta T sub F is equal to K of F times M, where K of F is a solvent constant, or the freezing point depression constant, and that for water is 1.86 degrees Celsius per mole. Boiling point elevation is delta T sub B is equal to KB times M, where KB is solvent constant, the freezing point depression constant. For water, that is 0.51 degrees Celsius per mole. Vapor pressure, we're looking at something called Raoult's law. Yeah, sounds really good, Raoult. Raoult's law says that the pressure of a solution is equal to the mole fraction of that solution times the original pressure of that solution. And the last one we're looking at, osmotic pressure, is the value pi. Pi is equal to molarity times RT, where R is ideal gas constant. Remember, we talked the ideal gas constant last year. Again, we need to take some more time with that. R is either 0.0821 liters atmospheres per mole Kelvin or 8.31 liter pascals per mole Kelvin. All right, so let's look at the first problem. Calculate the freezing point of 255.05 grams of water and 129.65 grams of ethylene glycol is dissolved into the solvent. So water is my solvent, ethylene glycol is my solute. So delta T sub F is equal to K sub F times M. We don't know the K of F because that's what we're looking for. It's water, but water in the solvent, so it's 1.86 degrees Celsius per mole. And we don't know molality, so we're going to have to solve for it. So we take our solute, 129.65 grams of ethylene glycol, that's what ethylene glycol is, C2H4OH twice, convert it to moles. 1 mole is equal to 62 grams, and we get 2.0911 moles of C2H4OH twice. And we're going to divide that by our kilograms of solvent. We have 255.05 grams of water. 1,000 grams is 1 kilogram, so we get 0.25505 kilograms. Divide through, I get 8.1988 molal. All right, so we take our equation. My KF for water is 1.86 degrees Celsius per mole. My molality is 8.1988 molal. Multiply through, I get a delta T sub F of 15.250. Now, I didn't ask for the change. I asked the freezing temperature. To find the freezing temperature, I'm going to take the pure freezing temperature of the substance minus the change. Well, the pure is 0 minus when we come up. Our answer is negative 15.250 degrees Celsius, and that's my answer. Okay, here's a problem we're looking at for boiling. We'll do this one in class. Here's one using Raoult's law for vapor pressure, and here's one for osmotic pressure. We'll do this as well. Any questions, let me know. We're done. Take care. Be good. Bye.